So in section 3.6, we're going to focus on the distance between given lines and a point not on the line or between two parallel lines. So to solve these problems, sometimes you would just be able to count the distance, but a lot of times you cannot. So we're going to figure out how to work through this algebraically. So when you're thinking about the distance between a point not on the line and a line, you have to find the distance that is actually perpendicular to that line from that point. So the distance between a line and a point not on the line is the length of the segment perpendicular to the line from that point. So if you look at this picture here, we've got all these different segments going from line L to point A. And so the distance between line L and point A would have to be the segment AD, because that is the only segment that is perpendicular to line L that passes through point A. So remember, it has to be perpendicular. You're finding the length of the segment. We would find the length between A and D. So if you're given a line and a point not on the line, then there exists, obviously that's misspelled, to fix that, exactly one line through the point that is perpendicular to the given line. So what we need to do is figure out, okay, we need this perpendicular segment that goes from P to line L, and we need to find that point where the segment intersects, and then we're going to find the distance between these 2 points. So we're trying to find the distance between those. So the first thing we want to do is write the equation of line L. So to write the equation, we first need to determine the slope of L. So we're going to have negative 9 over 9, which is negative 1. And so we're going to use a point, so I'm just going to use negative 5, 3. So we'll have y minus 3 equals negative 1 times x plus 5. So then we'll have y minus 3 equals negative x minus 5. So y equals negative x minus 2. So that's the equation of L. Alright, then we need to figure out the equation of the segment perpendicular to L that passes through P. So let's call that line M. Well, let's call it something else since we're already using M for slope. Let's call it line K. So it's going to be perpendicular to L and passes through P. So we know the slope of L is negative 1, so then the slope of K should be perpendicular to L, so that would be positive 1. And then we know the point P is 2, 4. So I'm going to use both of those to write this equation. So we're going to have y minus 4 equals 1 times x minus 2. So then we'll have y minus 4 equals x minus 2. So y equals x plus 2. So that would be the equation of line K, which is the line we're calling perpendicular to L that passes through P. So y equals x plus 2, y equals negative x minus 2. Well, I need to know where these two actually intersect so that I know what that point is right there where the two would intersect to be able to find the distance. So the third thing we're going to do is find the point of intersection. So in order to do that, we know we've got these two equations, y equals negative x minus 2 and y equals x plus 2. Remember, when we're solving systems, there's lots of ways to do this. So since both of these are set equal to y, I'm going to take each expression that's equal to y and set them equal to each other. So I'm basically using substitution. So we're going to have x plus 2 equals negative x minus 2. So then I'm going to add x to both sides. And then I'll subtract 2. And then we're going to divide by 2. So we get x equals negative 2. Well, once I have that, I can take this and substitute into either one of these equations to solve for y. So we're going to have y equals negative 2 plus 2, which would give us that y is 0. So the point of intersection is going to be negative 2, 0. So if we go back and look at the picture, we know, okay, this point should be negative 2, 0. So my estimation was close, but wasn't quite right. So the fourth part is going to be, because remember we're trying to find the distance between P and that line, and we have to use the segment perpendicular to that line that passes through P. So we're going to use the points negative 2, 0 and 2, 4 and find the distance between them. So we're going to have, remember it's x2 minus x1 squared, so 2 minus negative 2 squared plus y2 minus y1 squared. So 2 minus negative 2 is 4, so 4 squared is 16, 4 minus 0 squared is 16, so we get the square root of 32, which if we simplify, that will be 4 square root of 2. So the distance between that point and that line is 4 square roots of 2, and we would say units. So remember the steps. We had to find the equation of the line we were given, find the equation of the line perpendicular to the line we were given that passes through the point, find the intersection between the two lines, and then find the distance between the point of intersection and the given point. So I want you to go through this example and try to work out all 4 steps. So you should have work for every single step. And look back at the last example if you need it to be able to figure this out. So the other type of problem we have to be able to solve is finding the distance between 2 parallel lines. And the reason why we're doing all of these problems is it's going to help us later on when we get into polygons and triangles and trying to find certain segments and points. So that's why we're going through all this. So the distance between 2 parallel lines is the perpendicular distance between one of the lines and any point on the other line. So when we're working with 2 parallel lines, as you can see in this picture, there are lots of segments you could choose from. And we're going to apply this theorem. So in a plane, if 2 lines are equidistant from a third line, then the 2 are parallel to each other. So just remember that. We won't use it quite yet for this problem, I'm sorry. But we will use it in a theorem. A proof of a theorem. So find the distance between parallel lines L and M with equations y equals 2x plus 1 and y equals 2x minus 3 respectively. So what we have to do is pick one point on one line, find where it intersects the other line, that segment, and then find the distance between those two. So the easiest thing to do is to start with one of the y-intercepts. So I'm going to start with the y-intercept 0, negative 3. So I'm going to go from 0, negative 3. And I need to figure out this equation where it would intersect that other line. So we know the slope of L and M is both 2 because they're parallel. So then I need to determine the slope parallel to the lines. Not parallel, excuse me, perpendicular. So we know the slope of L is 2. So the slope perpendicular to L would be negative 1/2. So what we need to do is write the equation of the line that passes through this point that we picked and has the slope so that we know the equation of this line that contains this segment. So I'm going to say we're going to find the equation of the perpendicular line. So we know the slope is negative 1/2, and we're going to use the point 0, negative 3. Well, if we use that, we already know the slope, we already know the y-intercept, so we know the equation is y equals negative 1/2 x minus 3. So that would be the equation of this perpendicular line. Let's give it a name. Let's call it H. So we'll call this line H. So we already know this point is 0, -3. So what I need to do is find the intersection point here so that we can find the distance between those 2 points. So next we need to find the point of intersection between line H and line L. So just like we did before, we have the two equations. So we know line L is y equals 2x plus 1, and line H is y equals -1/2 x minus 3. So again, they're both set equal to y, so I'm going to take the expressions that are equal to y and set them equal to each other. So I'm going to add 1/2 x. So we'll have 2.5 x, which is the same thing as 5/2 x, plus 1 equals -3. Then we subtract 1. So we have 5/2 x equals -4. And then I'm going to divide by 5/2, which means I multiply by the reciprocal, which would be 2/5. So x equals -8/5. So that's the x value. So we've got -8/5. And so to find the y value, we need to take this x value and plug it into one of our equations. So we're going to have y equals 2 times -8/5 plus 1. So that'd be -16/5 plus 1. And we can rewrite 1 as 5/5. So that would be -11/5. So that would be our point of intersection. So take a look at that, see if you have any questions. If you do, jot them down and we can talk about them in class tomorrow. But then all we've found so far is this point of intersection here. This point is, let's give it some more room, -8/5, -11/5. So the last thing we have to do is find the distance between the 2 points. So the distance between 0, -3 and -8/5 and -11/5. So we're going to have the distance would be x2 minus x1, so -8/5 minus 0 squared plus y2 minus y1, so -11/5 minus -3 squared. And I want you to work this out and finish that problem, find the distance. And remember, if you have questions, bring them in to talk about them. Alright, so on this one, I want you to work it out completely. So find the distance between the two parallel lines, use the same steps we used on the previous problem. So bring those to class tomorrow, and we will go over both of those. I want you to skip the proof for now, but I want you to answer the 2 wrap-up questions also. So you have 2 problems to finish, and then these 2 wrap-up questions, and we'll go over it all in class. So I will see you then.